Okay, so lesson 5 in Unit 6, Moving Shadows. All right, so in the first few problems here, we're going to deal with this wagon. And the front wheel of the wagon is a circle. It has a diameter of 44, so that means it's got a radius of 22. And it says it has 12 spokes emanating out of the center there. The back wheel is larger. It has a diameter of 59, which is tedious because 59 inches, these are inches. That makes my radius half of 59, 29.5 inches. And it has 16 spokes. All right, so the area formula is pi r squared. So for the front wheel, that'll be 22 squared pi, which is 484 pi inches squared. The circumference is pi times the diameter. The diameter, the radius is 22, the diameter is 44. So pi times the diameter would be 44 pi inches. The rear wheel is going to be 29.5 squared pi inches squared. If you multiply that out, 870.25 pi inches squared. The circumference is the radius, the diameter times pi d, so that would be 59 pi inches. Okay, determine the central angle. On the front wheel, we got 360 degrees. We divide by the number of spokes, which is 12, and we get a 30-degree central angle. That means in that wheel, if we take 2 consecutive spokes, this angle in here will be 30 degrees. On the rear wheel, it's 360 divided by 16, which is 22.5 degrees. Find the distance between 2 consecutive spokes. So on the space for this on the front wheel, we had a circumference of 44 pi. That's all the way around. There are 12 spokes, so I'll divide by 12, and we'll call that approximately 11.5 inches. 11.5 inches. Same thing on the rear wheel. We had a 59 pi circumference. We'll divide by 16, and that'll give us approximately 11.6 inches. The wagons cover 15 miles per day. Right, so this is how many more times does the front wheel turn in terms of the back wheel. Okay, so to find out how many times it turns, every revolution of the wheel, it covers the circumference of the wheel. So we're going to take this is sort of like a chemistry thing. This is like unit analysis. We have 15 miles per 1 day. What am I writing there? And then we have 5,280 feet in 1 mile. And we're going to cover 12 inches. I'm going to get this into inches. 12 inches per 1 foot. So that gives me, 400 inches per 1 day. So the idea here is that by setting it up this way, if I change my colors here, and the first ratio, 15 miles per day, this miles cancels with that miles. Now I have feet per day, and then feet cancel with feet. So we multiply this all out. This is inches per day. So on the front wheel, we have 954,500 inches per day times one revolution of that front wheel is the 44 pi. And notice what we'll get here is revolutions per day. This will be, if you multiply this out, the 950,400 times 1 over 1 times 44 pi, you'll get approximately 6,875 revolutions per day. So on the back wheel, it will be the same 950,400 inches per 1 day, and times 1 revolution every 59 pi, because that's the circumference of that wheel, and that would give you approximately 5,128 revolutions per day. And if you take the difference in these two numbers, it's approximately 1,747 revolutions per day, and you get the difference between the revolutions. Okay. So keep in mind, this is inches down here and inches in those denominators, and what happens is the inches cancel out. You're left with revolutions per day. Same thing here, inches here, cancel inches here, revolutions per day. All right, so on to the set portion. On this first circle here, we don't have a unit circle. We have a circle of what that point is 5,5, and the radius is 5 root 2. You get that from special right triangles. And the cosine is, so this is a 5 here, and it's a 5 here, 5 root 2 there. Cosine is the adjacent 5 over 5 root 2, which is 1 over root 2, which is root 2 over root 2. And measure of angle Z, measure of theta, these are both 45 degrees. Okay, on the next one, we're in a different quadrant now. So this x coordinate is 5, the y coordinate is -5. This radius right here is still 5 root 2, special right triangles. So on this one, the cosine, again, is the adjacent over the hypotenuse. So that's, again, 5 over 5 root 2, which we discovered in the previous problem. It's root 2 over 2. And the angles, measure of angle Z is 45 degrees. The angle of rotation all the way around here is 315 degrees. Okay, on the next one, we've got the measure of angle Z is still 45 degrees. That's not going to vary much. The measure of, I take that back, that's not 45 degrees. My bad. Erase that. If in this case, if we have -4, let me pull this off to the side here. My x value would be -4, and this is 4 root 3. Now, if I think of the absolute value here, then this is a what? 30, 60, 90 right triangle. This would be 30, 60, 90. So the measure of Z is actually 60. The rotation is 120. So Z in here is 60 due to the 30, 60, 90, and the angle of rotation from here to here is 120. And our cosine now is going to be, think about the hypotenuse here. If we look at the absolute value of that -4 is 4, then this must be 8, because the hypotenuse is twice as big as the short side. So this would be 1/2 right here, 4 over 8. All right, on number 9, this is again a 30, 60, 90. So the measure of Z is 60 degrees. our rotation over to here is 240 degrees, and our cosine this time is going to be negative 1/2. The hypotenuse is 8. The absolute value there, that distance is 8. And so we get negative 4 over 8, which is negative 1/2. All right, number 10. This is again a 30, 60, 90 right triangle. And the reason for that, if I bring it off to the side, is that this would be 6 root 3. This is negative 6. Its absolute value is 6. Notice that the ratio is root 3 to 1 from the long to the short. So this must be a 12 over here, making my cosine 6 root 3 over 12, which is root 3 over 2. And then this angle right here, that's opposite the short side, so that's 30 degrees. And my angle of rotation all the way around here would be 330 degrees. Okay, I think there's one more of these. Yep. All right, so this one we have, again, I'll bring the triangle over here. It's 6 root 3 and 6. Notice the root 3 to 1 ratio means this is a 30, 60, 90, and this is a 12. That's my right angle. So measure of theta in problem number 11 is going to be 30 degrees. Both of these are 30s. We're in quadrant number 1. And the cosine is going to be root 3 over 2. That's 6 root 3 over 12 reduced. Okay, so in each graph, the angle of rotation is indicated by the arc theta. Describe the angles of rotation and the z-values when they're positive. So x is positive when we are from 0 degrees. Theta is between 0 and 90, and also when theta is in between 270 and 360. But we're saying the cosine is positive, basically in quadrant 1. X being the value of the cosine, or the x coordinate of a point. That's what. And then it's negative. X is negative when theta is in between 90 and 270. So the x values are positive in quadrants 1 and 4, and negative in quadrants 2. I'll put it to the side here. So from 0 to 90, my x value is positive. From 90 to 180, my x value is negative. From 180 to 270, it's also negative. And then from 270 to 360, it's positive. That's my x value over here. And it turns out that the x value divided by the radius is the cosine. So that's what the cosine is, positive. Okay, so what do we notice? I think I just explained that. The cosine is the same, the x value of the point as the same sign, positive versus negative, as the cosine does. Doesn't mean the x value is the cosine. If it were a unit circle, that would be true. But on a circle of radius other than 1, the cosine is the ratio between the x coordinate and the radius. Okay, and then in the graph of the result, number 14, in the graph, the radius of the circle is 1. The intersection of the circle and the axes are labeled based on your observations. What do you think about the cosine? Okay, so I'm going to go down here. So yeah, there we go. So at 90 degrees, which is up here, our x value is 0. So we're going to say that's a 0 for our cosine. At 180, the x value is negative 1. And at 270, it is 0. So we're on a unit circle. If I come over here and make a triangle like that, my radius is going to be 1. And so whatever this coordinate is here, x, y, my x will wind up being my cosine of theta. And my y actually, we'll find out, is going to be the sine of theta. Now, when you get to here, you don't really see a triangle because the radius goes out and back like that. But these would be the values we would assume. All right, enough of the trig. Now I guess we're going to do some algebra here. So on number 15, this is the multiplication problem. I would start by taking the numerator, and I'll work up here, and factor out a common factor of 3, and have a 5x squared down here. And then in my next numerator, I think we're going to have an x minus 3 with what, an x plus 2. It gives you the negative 6 and negative 1. And then x squared minus 4 is x minus 2 times x plus 2. Right, now we can start canceling factors that are in common. X plus 2. And that leaves us with quite a few factors remaining. We have, in the numerator, we have a 3. We have an x minus 3. We have an x plus 2. In my denominator, I have a 5x squared with a x minus 2. Right, so that's number 15. Okay, on number 16, this is again multiplication. I'm going to factor an x out of my numerator in the first fraction. I'll leave the denominator alone. Difference of squares in this numerator. And the difference of squares again. All right, so now let's see what we get. We get x minus 4s to cancel out. Get 2x plus 1s to cancel out. And that leaves us with what? An x with a 2x minus 1 in the numerator. And an x plus 4 in the denominator. All right, number 17. Again, multiplication, factor out of 4 in the first numerator. Denominator stays the same. 12. The factor is 6 out of here. We get 2 minus x. Now, keep in mind that this x minus 2 does cancel that 2 minus x, but it does not leave 1 behind. X minus 2 and 2 minus x are opposites. But then there's another negative sign over here. So when this produces a negative, when those factors, x minus 2 and 2 minus x, cancel out, the two negatives cancel out as well. This 6 divides into that 12 twice. And so what are we left with? In the numerator, we're left with 4 times 2, which is 8. And in the denominator, we're left with simply 3x. So that's that answer. Right, a few more to go. Number 18, we have to get a common denominator, which in this case is, I'm going to write it a little more precisely, or concisely, I'll call it. Here's my common denominator. These two factors are relatively prime. They have no common factors between them. So the 4 has to be multiplied by the missing factor in the common denominator, which is x plus 2. And the 2 has to get multiplied by the missing factor from the common denominator, which is x minus 1. What does that do? That gives me 4x minus 2x, which is 2x, I believe. 4x minus 2x is 2x. 8 minus 2 is what? Actually, it's 8 plus 2. So that's negative 2 times negative 1, so that's plus 10 over x minus 1 times x plus 2. Now, I would factor that numerator just to be sure I'm not going to get anything canceling out, and I do not. So here's that answer right there. Okay, that's not plus 12, that's plus 2. All right, number 19. What I'm going to do to this one is I'm going to change this denominator into its opposite by reversing 2 minus x to x minus 2. And the price I pay for that is I have to take the opposite of the numerator, and that makes it into a subtraction problem, which means I have 4 minus x over x minus 2. So keep in mind that if you change an a minus b into a b minus a, that these two are not equal, but they are opposites of each other. So if you have a fraction in which you have, an x minus 5 up here, and down below in the denominator you have a 5 minus x, you are allowed to cancel those out as long as you leave a negative 1 behind. All right, last problem. Common denominator is x times x squared minus 4, which means the 1 has to be multiplied by x squared minus 4, and it means the x has to be multiplied by an x. So the way I think of this is the original numerator, the 1, and it's multiplied by the factor that its denominator is missing from the common denominator, which is x squared minus 4. And then this x is my numerator from the second fraction, and it's multiplied by the factor it's missing from the common denominator. So I wind up with what? 2x squared take away 4 over x times x squared take away a 4. I'll check to see if anything cancels. Numerator factors as twice x squared minus 2. The denominator is x plus 2 times x minus 2. And these look sort of the same here, but not quite. So the final answer is right there. And I believe that is the end of the assignment.